So we'll be solving RLC circuit now. Okay. Right. In the following circuit below, the switch S has been at position A for a long time. Okay. So this was at position A for a long time. Now it's getting switched to position B at t is equal to 0. VCT, that is the potential across the capacitor, we need to calculate. Okay. So we need to find DC function, right? So when this is connected at A for a long time, that means this circuit has reached a steady state and the current okay, so what happens at steady state? What happens to the capacitor and what happens to the inductor? This we need to know, right? So when this is at a steady state, there is no current passing through the capacitor, and inductor behaves as a short circuit. So at steady state, capacitor becomes as an open circuit, okay, and inductor becomes short circuit. So this is open circuit versus plus this short circuit. So ultimately this will be open circuit only, right? So at steady state, this is the circuit when this is connected at A for a long time. Which means what? Which means what is the potential drop across this two node? It will be half of this, right? Because 50 ohm, 50 ohm, 4 volt is applied. So 2 volt will be the potential drop across this. Which means the 2 volt drop will be here as well. So VC 0 is 2 volt. Okay? Right? Because this is open circuit and this guy is anyway short circuit, right? So this and this will be at same potential. So this so potential drop across this capacitor will be 2 volt. So now we know the initial state of the capacitor. Okay, and also what's the current from here? IL0 is also 0 because this will be ultimately open circuit, right? Even though this is short circuit, this guy is open circuit. So current, initial current across this is 0. If it is useful later, right? I just wrote it here. Now this is connected to B, right? Sorry, B, it's not putting, right? B is like this. So it's when it's connected to B, this is gone. This is connected. Okay. So the circuit becomes, these two will be coming in parallel, right? So this will be effectively 25 ohm, right? 50 ohm, 50 ohm, two of these resistors are in parallel. So this will become 25 ohm. Now this is the circuit we need to solve. Now there is no independent voltage source now, right? Then how there will be a potential drop across this? Because these two guys have stored charge, right? So that charge will be now circulated here in this circuit. Okay. Okay. So what happens? The current flowing from this will be equal to current flowing from this, right? So V by 25 plus your, so actually this will be 0 minus this, right? This is the current flowing in this direction will be equal to current flowing across this, which is C dV dt, which is V1 minus V2 here, potential across this, right? So this we need to solve. Now we need to replace this V2. V2 we know will be equal to L di dt, right? So this is minus V by 25. Okay, let's take both of these in the same direction. This will be C dV1 dt minus C dV2 dt, right? Which will become I can be written in terms of again V by R, right? Because it's actually negative V by R, so this becomes positive. So the equation would become LC by R d2V dt2 plus C dV dt plus V by 25. Okay. So equals to 0. So let's keep it in terms of R only, right? So this is the equation. So how to solve this quadratic equation, right? So you can say that V would always be equal to e to the power something mt. Okay. Now if you do S transform, then also it becomes easier, but let's say we are not using S transform, so you can assume the solution to be v is equal to e to the power mt, right? So then this will become ultimately m square, and this coefficient, right, LC by R plus Cm plus 1 by R equals to 0. Now replace all these values, so you'll get again we can multiply it by 150, so this coefficient will become 1, this coefficient will become 5, and this coefficient will become 6. So this guy is basically now m square plus 5m plus 6 equals to 0. Yeah, so m will be your -2 and -3. These two solutions are there, right? So what it means is that v1 is actually a sum of two exponents of -2t and -3t. Okay. Now how do we find this a and b, right? So first of all we need to find vct, right, not v1. So v2 is what? v2 is l di dt, and I is nothing but again v1 by r, so it's l by r, derivative of this guy, right? Derivative of this guy is what? A e to the power -2t, so it will become -2a minus 3b to the power -3t, right? And what's l by r? L is 5, and then by 20, so 1 by 5 minus 2a e to the power -2t minus 3b e to the power -3t. So you subtract this, right? Because that's the VCT. VCT is v1 minus v2, which is again. Now what you can do, see, this is also has to sum e to the power -2t and then e to the power -3t. This coefficient doesn't matter. VC will also be some coefficient, let's say c e to the power, okay, -2t and b e to the power -3t. Now why I did this because a and b are anyway unknown, okay, and even after solving this you will get some coefficients, right? And to solve those coefficients what we need is the initial condition, right? So it doesn't matter if it's 2c or 2a or something like that, right? It's basically a coefficient which is unknown. Now to solve this what we can do is use the initial condition. We know that at t is equal to 0 this was 2 volt, right? So c plus d is equal to 2. Okay. Now two variables, we need one more equation, right? What else do we know? We know that IL is equal to 0 initially, which is nothing but I is nothing but c dv dt, which is 0 initially. Means if I do derivative of this, so c into -2 plus d into -3, this has to come to 0 because at t is equal to 0, right? So you solve this equation and this equation, so you'll get your c and d values, okay, and it will turn out that c is equal to 6 and d is equal to -4, right? So you plug this in here and then you get the answer.